Okay. One moment. I will get this sorted. I'm very close to being organized. I'm also trying to convince my cat to not jump on my computer, but to sit on his cat bed, which must be lovely and comfortable, and is that going to share? It is on the desk next to me. Let's see if it sticks. Okay, so we're revising trigonometry. Yes, now I have a calculator. These first two questions use the fact that if you've got any triangle, let's call this A, B, and C, and let's call this theta. If that's theta, then this angle up here must be 90 take theta, because, all three add up to 90, which means sine of theta is B on C. But what's cos of 90 take theta? What? It's also B on C. So sine theta is the same as cos of 90 take theta, and vice versa. Cos theta is the same as sine of 90 take theta. So for question A, if we've got cos x take 20 equals sine 40, so let's let theta be 40, then x take 20, if they're for them to be equal, must be the same as 90 take theta, 90 take 40. I didn't really need to do the theta step, let's be honest. Yeah, let's get rid of that. Hide my shame, which means x take 20 must be 50, so x must be 70 degrees for cos of x take 20 to come out the same as sine 40. For question B, we've got sine 2x equals cos 110. Let me stash this over to the left hand. I want to fit this one in. So if we've got sine 2x equals cos 110, then 2x must be the same as 90 minus cos minus 10. I mean, I could have done 90 minus 2x equals 10, but this one's easier. So 2x is 80, x is 40 degrees. So sine of 2 times 40 is the same as cos of 10. Let's double check that. Sine of 2 times 40 comes out as 0.98. Cos of 10 comes out as the same. Okay, now if we're fully simplifying 3 sine 75 over cos 15, well, 75 is the same as 90 minus 15, yeah? So that's the same as 3 sine 75 over, well, cos 15 must be the same as sine 75. So it's just going to come out as 3. Okay, these ones, we're just looking at triangle A, B, and C. A is the op, B is the adjacent, and C is the hype. So if I'm doing cosec, now don't forget cosec means 1 over sine, so it's sine upside down. So instead of A over C, it's going to be C over A. Cosec of 90 minus theta, so now I'm looking at this one. Well, sine of 90 minus theta would be B over C, so it's going to be C over B. Cot of theta is opposite of tan, so instead of A over B, we're going to be B over A. And I keep saying opposite, I should say reciprocal, the upside down, because this is Stranger Things. Sec of 90 take theta, this time instead of being cos 90 take theta, which would be A on C, we're doing sec, so it's C on A. Sec theta, instead of cos theta would be B on C, and so it's C on B. And cot of 90 take theta, so tan of 90 take theta would be B on A, so it's A on B. And it's not letting me write A on B. Okay, hooray, what are these questions? We've got a plane. It's flying south 30 degrees east. So if I did my little north-south, then south 30 degrees east is that one for 15 minutes at 400 kilometers an hour, which means it's traveled 100 Ks. So this is A, this must be B. And then it's turned sharply to fly due east for 30 minutes. So it's still going 400 Ks an hour. So this time it's gone 200 kilometers to C. Find how far south and east from A, B is. So essentially what I want is how far south and how far east. So I'm going to call this one Y and this one X. And this is just your normal SOHCAHTOA type question. So for question A, we've got 30. If I solve for X first, so I find how far east it is, we're going to use that's opposite and hypotenuse. So we're going to use sine 30 is X over 100. So X is just going to be 100 sine 30. If you remember from your exact values, sine 30 is a half. So X is 50. Okay, so it's 50 kilometers east. Now we could use Pythagoras or we could use SOHCAHTOA again. I'm actually going to use Pythagoras. So I've got square root of 100 squared take 50 squared. So it's the square root of, I do have a calculator, I can do this. So it's the square root of 7,500. If I want an exact value, 25, 100 goes into that. 100 times 25 times 3. So square root of 100 is 10. Square root of 5 is 25 is 5. 5 times 10 is 50. Root 3 kilometers south. Okay, find the true bearing of C from A. So this time we want to go from A all the way over to C. I'm really regretting putting this working out here. I mean, I knew I would. I just kind of hoped I could get away with it. Whenever they're talking about a true bearing, they want it from true north. Don't forget this section of it's going to be 90, and then this extra section is going to help us find the extra bit. But in order to be able to find that angle, I should start off by trying to find this angle. I'm just trying to think. Ah, yes, okay. So what I can actually do is draw this overall triangle. Because I know how far south it is. It's 50 root 3. I know how far along it is because this is 50, this is 200, so it's 250. And I can find this whole angle and then subtract. Yeah, this whole angle will be this whole angle. And then if I subtract those from 90, I'll be able to find this extra bit, etc. So I'm just going to call this theta. So if I use tan, I know tan theta is 250 over 50 root 3. So it's 5 on root 3. So theta, I'm going to use my calculator, make sure it's in degrees, arctan, 5 on root 3. Now, I know that we usually like to use radians, but for any kind of real life question, we'll use degrees. Real life. So that comes out as 78.9. I'll do degrees in minutes later. Which means this extra bit I don't even need to know that extra bit, really. Which means this extra bit is going to be 90 minus that, because all of these add up to 90. So 90 minus 70.89 is 19.1066 degrees. And then, so true for from true north. Oh, I'm just going to end up plussing another 90 on anyway. Uh, 109.1066 degrees true. Degrees, minutes, seconds. 109 degrees, 6 minutes, 24 seconds. True. True. Exact values, hooray, back into my comfort zone. Cosec, don't forget you look at the third letter to figure out what it is. So cosec is going to be sine upside down. So sine 30 is 1 on 2, so it's 2 on 1. Cot 45, so cotan is tan upside down. So tan 45 is actually just 1, so it's just 1 upside down, which is 1, which comes out as 3. Sine 45, on the other hand, is, I must have cropped out the tan values for these. Tan of 0 is 0. Tan of 30, 1 on root 3 or root 3 on 1? Tan 30, 1 on root 3. Tan 45 is 1. Tan 60 is root 3 on 1. Tan 90, undefined. Okay. Sine 45 was 1 on root 2. We're dividing that by sec 60 squared. Now, sec 60 is 1 on cos 60, so it's cos 60 upside down. So it's half upside down, so it's 2 on 1. Don't forget we're squaring it. So I've got 1 on root 2 divided by 4 on 1. So I've got 1 on root 2 times 1 on 4. So we've got 1 on 4 root 2, but they've asked us to give it with a rational denominator, root 2 on root 2. So we've got root 2 on 8. All right, these questions are kind of similar. So let's do question 11 first. They've told us that sec theta is 3. Now, whenever you're given one of the ratios, like sine, cos, tan, sec, cosec, cot, and you're trying to find others, you always kind of draw yourself a basic acute triangle. We know we just make one of them theta. I always make that one theta. We know sec is 3. So sec is cos upside down. So if sec is 3, then cos must be 1 on 3. Now, cos is adjacent. Cos is adjacent over hypotenuse, so it's 1 over 3. To figure out the other side, we use Pythagoras. 3 squared take 1 squared, so it's root 8, which is the same as 2 root 2. Okay, which means tan theta must be 2 root 2 over 1. And we don't bother writing the over 1. And sine theta is 2 root 2 over 3. And they specifically said theta is acute. That made that nice and easy. Example 12, though. They said cos x is negative 2/3. And we're between 90 and 180, which essentially means that we're here. So this is the triangle we're looking at. Now now that we know which area we're in, we're going to ignore the negative. Now cos is 2 on 3. Now cos is adjacent on hypotenuse. So the opposite must be square root of 3 squared take 2 squared, which is root 5. which now means sine theta must be, is that what we're finding? Sine and tan, good. Sine is then opposite over hypotenuse, so it's root 5 on 3. Sine is going to be positive because we're in the sine quadrant. Tan theta, opposite over adjacent, so it's root 5 on 2. But we're in the sine quadrant and tan's negative. Good. And example 13, let me just copy this. 15, sorry. Okay, this time we know, I may as well do this one nice. We know we're in the third quadrant between 180 and 270. I'm going to make this one our theta. We know tan of that. Oh, I should have, instead of theta, I should have done x. Tan is 3 on 2, so tan's opposite over adjacent. Which means the hypotenuse must be the square root of 3 squared plus 2 squared, so it's root 13. Okay, now cosec is 1 on sine, so sine x in this case is going to be negative, and it's going to be 3 on root 13. So cosec is going to be negative root 13 on 3. And if we've got cos, oh, this one's easy. Cos is adjacent over hypotenuse, 2 on root 13. And if they're pedantic, that's 2 root 13 on 13, if we rationalize it. Okay, finding the angle of this one. Oh, my cat's enjoying his cat bed. You don't understand, he has never sat on that. He's always sat next to it. Good boy, Henry. You're a good boy. Okay. Hopefully you remember L equals R theta. If we've got 2R equals R theta, then theta must be 2. I hope I got that formula right. I can't bother looking it up. It makes sense to me. That was a very easy question. So it's 2 radians. Oh, I should do my little radian sign. The arc of a circle subtends an angle 100 degrees at the center. The radius is 2 centimeters. Find the exact length of the arc. So L equals 2 times, not 2, R times theta. So we've got L equals 12 times theta, which is 100 degrees. But we want the exact length. We don't ever use 100 degrees. We don't ever use degrees with this formula. We use radians. So remember, 100 degrees, to turn it into radians, we times it by pi, divide by 180. So we've got 5 pi on 9. So we've got 12 times 5 pi on 9. Let's cancel these out. 4 and 3. So we've got 20 pi on 3. Hooray, that's the answer. That's the exact length. The minute hand of, oh, I love these questions. The minute hand of a clock. I love them while I'm reading them. Minute hand of a clock, 20 centimeters long. If it's going 16 minutes, that means I'm just going to do minutes hands, ignore the hours. It's going from there to there. There's 60 minutes all the way around, and it's going 16 minutes of it. So what we've got equals, well, we've got 2 pi all the way around, but we've only got 16/60ths of that, which means we've got 8 pi on 15. Hopefully, I just cheated. 2 times 16 on 60. See, without a calculator, I would have been able to do that in my head. Because I have one here, I can't. The exact arc length along which the tip of the hand travels in 16 minutes. So L equals R theta. So our radius was 20 centimeters long. Our angle is 8 pi on 15. So we've got 32 pi on 3. And question C, the shortest distance between the initial and final positions of the tip of the hand. So we want this one. So now it's a non-right angled triangle. We've got 20, 20, 8 pi on 15, and we want this distance. So we're going to have to use the cosine rule. So we're going to have d squared equals 20 squared plus 20 squared take 2 times 20 times 20 times cos 8 pi on 15. Yeah, let's just chuck it straight in the calculator. Don't forget to turn your calculator into degrees, into radians, because I just completely forgot. 883.86. So D is 29.73 centimeters. Excellent. Okay. Now we're trying to find out some information about the area of a sector. Sorry. Okay. So we know our radius is 15. We know the arc length is 10. If we want to know this angle, we just have to do L equals R theta. So theta is the length over the radius. So we've got 10 on 15. So we've got 2/3 a radian. The exact area of the sector. So for this one, the area is half times the radius squared times the angle. So we've got half times 15 squared times 2/3, which gives us 15 squared is 225 times 2, 550 divided by 6. That gives us, I've got something wrong. Yeah, I shouldn't have tried to do that in my head. Half times 15 squared times 2/3. It does come out as 75. The problem was me. What is prize? Henry, you're a good boy. Sorry. He's never used the capital ever. It's 6 months old now, and this is the first time he's used it. Oh, there's that formula. Yeah. You know how to derive this. So the area of a segment minus segment comes out as that. Let's find this information. So we've got the length is 16 centimeters. Oh no, that's the length of a minor arc. My apologies. Let's actually draw it. So this is point A, and this is point B. This bit across here is 16. The radius of the circle is 10. first thing we're going to do is find this angle. We're going to use the cosine rule. So we know cos of this angle is 10 squared plus 10 squared takes 16 squared over 2 times 10 times 10. So that gives us negative 56 over 200, negative 0.28, which means the angle itself cos that answer 1.85 degrees. It's annoying me that I can't get that exactly. Did I do something wrong? No. Okay. The length of the minor arc AB. So this time we want this distance around here, which is easy because L equals R theta. So we've got 10 times the 1.85 radians. So 18.54 radians. And if we want the area, then we're going to do half times 10 squared times. We have our, in my calculator, I'm actually going to be doing arc cos negative 0.28 minus sine of arc cos negative 0.28. I'm just doing this so that I don't have it come out like less accurate. I mean, technically, I'm actually going to be using answer for both of these because I didn't put this one in my calculator. I just didn't move the decimal in my head. So we've got a half times 100 times, now this thing we've got answer minus sine of answer, 0.8946. So times that by 50. We get 44.73 centimeters squared, I'm assuming. Okay. And I should highlight this one so you know that that was my answer. Okay, the value of this one, we're going to use the sine rule. So we know that A on sine 73 is the same as 15 on sine 41. So this is nice and easy. We've just got 15 sine 73 over sine 41, calculated back in degrees. So we've got 21.9 centimeters. Okay, we want to draw a diagram for questions like this. So I always just kind of start in the middle because I honestly don't know if I'm going left, right, up, down. So this is P. It's flown from P to Q. It's going to help us if we do a little rosette. So if it's going 200 degrees, that must be, that's 90, 180, 200's down this way. And that's 160. And this is Q. It then turned and flew 225 kilometers to R, which is due west of P. So R must be this way because that's straightly west of P. And we want to know the bearing of Q from R. So what we're asked is this one. What we know is that this bit is 20 because all the way around to here is 200, which means this bit is 20, which means this bit must be 70. So what we're going to find first is I'm going to call this theta. We're going to use the sine rule to find theta and then plus 90 on it, and we'll get that bearing. So we know sine theta over 160 equals sine 70 over 225, because it's always the opposite angle inside. So sine theta is 160 times sine 70 over 225. So we'll arc sine that to get theta. So arc sine 160 sine 70 on 225. So we get 41.93 degrees. So that's just this tiny little bit, which means the bearing, we've got 90 plus that. So we've got 100, it's about 132 degrees, and that's around from true north. So bearings are always around from north. All right, this question. Starting to lose my voice. We've got a few different diagrams, and what we're essentially going to have to do is split this triangle up into a few different triangles to then find some values for some stuff. So for example, my first triangle is A, B, D. This is 55, and this is H. The second triangle I have is this non-right angled triangle, D, C, and A. And I know this is 23, and I know this is 200. I also know that this bit is 180 take 55, which is 125. The last triangle I'm going to have is them kind of together, A, B, C. So this is going to be H. This is 90, and this is still 23. But I don't have any other piece of information. Let me just make H the same color. So what I really want is B to C. I know D to C, but I don't know D to C, it's that one, it's 200. But I don't know, what color should I make orange? B to D, I don't know this length of it. So once I add them together, I'll get that whole bottom, and then I'll be able to use SOHCAHTOA to find H. Okay, in order to find B to D, I would need a bit more information. So if I find A to D, which is what they're leading us through, A to D is this one. It's the same as this one. And this triangle in the middle is the one I know most about. So that's why they're getting us to do AD first. So AD, we're going to have to use the sine rule, I think. If that angle is 23, that angle is 125, then this top angle must be 180. Take those. 32. So we know angle DAC is 180 take 125 take 23 is 32, which means if I want length AD, using the sine rule, it would be over sine 23, because that's the opposite angle to that one. And that's going to be the same as 200 over the opposite angle, which is the 32 we just figured out. So we've got length AD equals 200 sine 23 on sine 32. And that's the first thing they asked us to find. Question B. So that AD is the same on both triangles. So if I use SOHCAHTOA, I know that sine 55 is going to be H over that hypotenuse, which is AD. So we've got h is going to be sine 55 times length AD. So we've got sine 55 times, well, length AD was 200 sine 23 over sine 32, which is what they got. And we'll just rewrite it as they have. 200 sine 23 sine 55 over sine 32. After that, it's just a matter of mashing it in our calculator. So we've got 200 sine 23 sine 55 on sine 32. 120.80 meters. The exact area of this one, there's a lovely rule. Area is half times A times B times sine of the angle in between. So we've got half times 3 times 4 times sine 135. Calculator. Exact area. Sine 135. 135 is over here, and that must be 45 there. So we've got half times 3 times 4 times sine 45 is 1 on root 2. So we've got 6 on root 2, which is the same as 6 root 2 on 2 or 3 root 2 centimeters squared. How big's your patio? 3 root 2 centimeters squared. Well, not centimeter, you know what I mean. Okay. So area is half times AB times sine the angle in between. So we know 72 equals half times x times 24 times sine 67. Rearrange and we get x equals, so we've got the 72 times 2 divided by 24. 6 over sine 67, chuck it in calculator. I'm in degrees, yep. 6.51816 centimeters. They wanted 4 significant figures. Don't forget significant figures. You include the first, like the ones before the decimal, as long as it's not a 0 at the start. Decide whether to round up. In this case, we won't. So it's 6.518 centimeters. Okay, triangle KLM. KL is that length, LM is that length, that angle is that, yada, yada, yada. Bisect just means the angle's cut in half. We want to find the exact value of the area of KLM. So let's draw this a bit more simply. We know this is 60. We know this is 3. We know this is 6. LKM. So area, we've got half times 3 times 6 times sine 60. So we've got 9. Sine 60 is root 3 on 2. Yep. So we've, yeah, that's just 9 root 3 on 2. Centimeters, units, squared. Hence, otherwise find this little length here. I don't think that that would help. I've made, no, that's not perpendicular. That's not. Okay, well, I'm not sure what to do. This is exciting. So let's start off. Let's find an expression for Km. I don't think that's actually going to be useful though. No, okay. Let's split up these triangles. All else fails, I'll actually Google the exam and find out. So we know because part of me is screaming out to find Km, but I can't think of why it would be useful. Like they should, those, can I prove that those lengths are in a certain ratio? Can I prove that those areas are in a certain ratio? Will finding this angle particularly help? I know Km squared is 3 times 6 times sine. Oh no, my apologies, cosine rule. 3 squared plus 6 squared, take 2 times 3 times 6 times sine 60. So Km is going to be 45, take 36 times sine 60 root 3 on 2. Okay. I'm sure there must be just an easy way. Like, should I be able to assume that that is the same as that? Apologies, I'm Googling. Oh, sorry, Henry, I didn't mean to disturb you. What paper was it? 2018. Third computer. Oh, hurry up. Oh, I don't even, stop trying to make teams happen. I don't even know which question it is, so I'm just gonna have to like look it up. 2018, 2-unit HSC. I'm trying to figure it out just from a PDF of the answers. And I don't think this was the smartest way to go about it. Okay, it's question 14A. Ah, okay, so I'm a bit of an idiot. It happens sometimes. This triangle plus this triangle, those areas added together must be 9√3, yeah? Okay. So we know half times 3 times x times sine 30 plus half times x times 6 times sine 30 equals 9√3 on 2. Let's just double everything. So we've got 3x times sine 30 plus 6x times sine 30 equals 9√3. Now sine 30 is a half. So we've got 3 onto x plus 3x equals 9√3. 3 on 2 plus 3, 4.5, 9 on 2. 9x on 2 equals 9√3. So that means x must be divided by 9 times by √3. It's 2√3 centimeters, meters, units. Not the sharpest tool in the shed, but you know, I'm a tool, so it was useful and we got there. Okay, next one. Without using a calculator, find this. We've got a triangle X, Y, Z. Which means this one must be little x, this one must be little y, this one must be little z. They've told us x is 2, y is 5, cos z equals positive 4/5. Now, cos is positive. And this triangle is less than 180. So, and we're trying to find this little z. We're going to use the cosine rule because z squared equals 2 squared plus 5 squared. Take 2 times 2 times 5 times cos z. We know cos z, it is 4/5. So we've got z squared equals 29. Take 16. So z squared is 13. So z is √13. Question B. Again, we've got triangle BCD. Doesn't matter how you draw it. Doesn't matter what goes where. BCD. Little b equals 5. Little c equals 6. I'm always doing these opposite their big angles, by the way. Little d equals 7. Cos of b. So we want cos of this one. So cos of b is 7 squared plus 6 squared, take 5 squared on 2 times 7 times 6. So you've just got to make sure the 5 is opposite it. That's a calculator job. 7 squared plus 6 squared, take 5 squared over 2 times 7 times 6, 5/7. Beautiful. This one, find the value of x. Oh, that's a straightforward application of the cosine rule. So x squared is 11 squared plus 8 squared. Take 2 times 11 times 8 times cos 115 degrees in calculators in degrees. So x is going to come out as, and we'll square it, the answer, 11 squared. Squared, take 2 times 11 times 8 times cos 115. Square it this answer. We get 16.1 centimeters, I guess. Okay. They drove from E. So I'm putting E smack me in the middle because I don't know where I'm going to go with this, to F. And they've given us a bearing. So it's going to be easiest if we do our rosette. The bearing is 345. So 90, 180, 270. We're going up that way, which means this little gap here must be 15. And that's F. Okay, they then turned and went on another bearing. And that was 42. They then turned and drove on a bearing of 240 degrees. So again, 90, 180, 270 must be down this way. It's 73 kilometers, and this gap was 30. And we want the distance, and that's G. We want this distance here. So it's going to be easiest if we find out some other angles. So, for example, I'm going to blow this up. I should have done it way bigger to start with. I know, using my Z's, my alternate angles, I know that this one must be 15. I know if that one was 30, this one must be 60. So all up, the angle opposite the side we're trying to find is 75 degrees. And now it's just a cosine rule question. We know that, and I'm going to call this D. D squared equals 73 squared plus 42 squared. Take 2 times 73 times 42 times cos 75. Calculator. So that means I've already square rooted it. So it's 74.2 kilometers. That's fairly straightforward. It's just all about drawing your picture, drawing it big, using some color. This one, oh, this is a nice, easy question. Okay, cos A. So we're after cos of this angle. Is that, so we're just going to use the cosine rule. So I know cos A equals, it's the ones on either side minus the opposite one. So 8 squared plus 6 squared minus 4 squared, all over 2 times the ones on either side, 8 and 6. I'm putting that straight in my calculator. 8 squared plus 6 squared, take 4 squared over 2 times 8 times 6, 7/8. By finding the exact value of sine A, determine the exact value of the area ABC. I mean, we could be incredibly lazy. If cos A is 7/8, this length must be 8 squared, take 7 squared. So 8 squared, take 7 squared, root 15. Okay, so sine A is then root 15 on 8, which means the triangle area is half times 8 times 6 times sine A, which is root 15 on 8, which makes it 3 root 15. Ha, hooray. It's always nice when you have an answer to check against. All right. Got some water in a pipe. Find as an exact value the distance from the center of the pipe to the water surface. So I'm going to call this D and make myself a little triangle. We know this angle must be 60. And this length, because they've told us that length is that one across there. So this must be 8. So we know tan 60 is opposite over adjacent. So D is 8 on tan 60. Tan 60, can't bother remembering it. 8 on tan 60. Root 8 on root 3, which is 8 root 3 on 3. The diameter of the pipe. So now this time, the diameter, I wish I hadn't used D. I'm going to use Y. I could use Pythagoras or I could use SOHCAHTOA. I always try and use the one that I didn't have to figure something out. So I'm not going to use Pythagoras here. Pythagoras will be easier, but that relies on me having gotten 8 root 3 on 3 or 8 on root 3 correct. So this time I'm going to use sine 60 is 8 on the diameter. So the diameter is 8 on sine 60. So it's 8 on sine 60 is root 3 on 2. So we've got 6. Is it? Yes, it's root 3 on 2. So we've got 16 root 3. But that wasn't the diameter. That was actually the radius, wasn't it? So the diameter is 2 times the radius. So we've got 32 on root 3. And the maximum depth of the water. Actually, I should do this different color. Well, the whole way down must be the same as the radius. So I know y plus h, so the distance to the water surface plus the depth of water must be the same as the radius, which was 16 on root 3. So I know 8 on root 3 plus the height, the depth of the water, which I'm calling h, 16 on root 3, which means 16 on root 3 take 8 on root 3 is just 8 on root 3 centimeters. Okay. This question, bit nasty because they're asking you to do a whole bunch of stuff at once, but you know, it's perfectly valid for the exam. I'm going to draw these triangles separately and put in the pieces of information that I know when I can. So my first triangle, for example, DC sorry, BCD. This is the top of the tower. H for height of the tower. The other triangle I know is ADC, because they've told us the elevation of D from A is 5 degrees. This is still H. And if we do a bird's eye view, BCA, A and B are 500 meters apart from the ground. And one more triangle, BAD, 500. We know this angle is 59. And this angle is 54. Makes this angle 67. Okay, we must be able to find something useful. Let's start off by finding length BD. We're going to have to use the sine rule. So BD on sine 59 equals 500 on sine 67. So we know BD is 500 sine 59 on sine 67. That BD is the same here. That's not very useful though, because that's not the one with the 5 degrees in it. So let's do the same for AD. We know AD on sine 54 is 500 on sine 67. So AD equals 500 sine 54 on sine 67. Okay. So now we've got a bit more information. So let's draw this other triangle again. ADC, this is H. We know this is 5 degrees and we know AD. Let me get rid of this. I'm just going to pretend I didn't do that. So we know that sine, let me color this one in blue so I know for myself. We know sine 5 equals H on AD. So H is sine 5 times the length AD, or AD times sine 5. So it's sine 5 times 500 sine 54 on sine 67. And we're just going to rearrange that so it looks more like the answer they've given us. 500 sine 5 sine 54 over sine 67. And then that's a calculator job to the nearest meter, they say. So we've got 500 sine 5 sine 54 over sine 67. The hardest bit with this is the brackets. 38.29, so 38 meters. Next question. Similar kind of deal. So they're talking about OA and 15 and H. So they're starting off by talking us through this triangle. So we know tan 15 is going to be H on OA, which means OA is H on tan 15. Don't forget cot is tan upside down. So OA is going to be H times cot 15. We normally wouldn't write it like that. It must be useful for the next one. Hence, find the value of H. Well, we've been given a few more pieces of information. We know this one. We know OB is going to be H cot 13. And we know let me just pull this down below. We know AB is 200, 2000, it's 2Ks. So we know OB squared equals OA squared plus 2000 squared. Let's start putting these in because we're just after H. So we've got H cot 13 squared equals H cot 15 squared plus 2000 squared. So H squared cot squared 13, H squared cot squared 15, 2000 squared, which means if I take everything with H over to the left and factorize, I've got H squared outside of cot squared 13 minus cot squared 15. So we've got H squared equals 2000 squared over cot squared 13 minus cot squared 15. Let's continue that over here. So H is 2000 over the square root of cot squared 13, take cot squared 15. Now let's see if that's not going to come out nicely. We could just chuck it in the calculator in one fell swoop. Don't forget cot is 1 on tan. So 1 on tan 13 all squared. Take 1 on tan 15 squared. Square root it. 2000 divided by answer. I got 909.70 kilometers, meters. Okay. Sketching trig functions. We're nearly at the end. 5 cos 4x. So it's happening 4 times as often, and it's going up to 5 and down to -5. And they want it from -180 to +180. I didn't count this, so fingers crossed. I'm used to doing these in radians. It's weird to think of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -45, -90, -135, -180, 45, 90, 135, 180. Now, normally cos would look like this in this domain, but we're happening 4 times as often. Wait, I've really just confused myself. Just let me continue these. Okay. I hate that. Okay. And 3 tan 2x, same domain. Again, it's usually easier to draw the normal tan and then do this on it. 0, 45, 90, 135, 180. Now, normally tan has asymptotes every pi on 2. So normally it would look, we're not going to worry about the stretch factor. Kind of like that. This time we're happening twice as often. So we're going to have asymptotes like this. Are we? No, I'm second guessing myself. And I can't type Desmos. Yeah, that's it. Cool bananas. Okay. -4 cos half x from 0 to 2 pi. So we're going down from -4 to +4. Now, normally, if I take into account the stretch, pi on 4, pi on 2, 3 pi on 4, pi, 3 pi on 2, 2 pi. Okay. Normally cos is going to hit these marks. because it's upside down, it would hit these marks. Half x, so it's happening half as often. Mean it's going to hit there. 3 sine 3x, so this time it's going to happen 3 times as often. This is going to be a doozy. So normally pi on 2, pi on 2, pi 3, pi on 2, 2 pi. So normally sine 1, 2, 3 would hit those marks. But this time it's happening 3 times as often. Wait. And it's just going to keep happening. Wait. There we go. Smooth. Let me just double check. Yes, that's 1, 2, 3 times. Okay. Now 4 cos x take pi on 6 means it's moved pi on 6 to the right. So instead of being 0, 2 pi, pi on 2, pi 3, pi on 2. Now pi on 6 is going to be essentially all of these are going to be moved right by pi on 6. And if I want to solve where that comes out as 0, it's root 12, which is same as 2 root 3. Okay, half sine 2x take 1. Ugh. I think I'm going to have to actually solve this. That makes it annoying. Do I? Because I know it's moved right 2. And I know it's moved, I know it's moved right 1. Now it's going to be easiest to actually solve it. Y-intercept. Make x equals 0. Y equals half sine -1. Which we this is really annoying. Plus it's out of the scope of the year 11 course, so let's skip it. No, let's not. Sorry, I haven't had lunch. So we've got y equals half sine 2x take 1. So its amplitude is obviously a half. So it's going to go up to positive a half and down to negative a half. Its period is pi on 2. Instead of being 2 pi. And it's been shifted 1 right. So instead of doing this, let me try that again. Instead of doing that, our new period is pi on 2. So it's happening every pi on 2. And it's been shifted 1 to the right. So it's going to look kind of like that. Okay, so if I have 2 sec x plus pi on 3, then that we're going to have to start off by drawing cos. Now, this is not in the scope of the course, as far as I can tell. So this is negative pi onto negative pi, pi onto pi. No, I don't know why it made it go along so long. So if I was just drawing cos x plus pi on 3, or if I was just doing cos x, or 2 cos x, Oh, wait. It would look like that. It's been moved right pi on 3. So it's going to look kind of like that instead. But because we're doing sec, we have to realize that whenever this comes out as 0, we're trying to do 1 on that. And for example, this is the number 1. So we're going to do 1, but we're doing 2 times it. So we're up here. We're just going to get something that looks like this, essentially. It's weird. It's outside the scope of the course anyway. Given this, find 3 solutions of the equation sine x equals half x. Well, let's draw on half x. So when x is 1, we're only going up to a half. Of course, they've made this. When x is 2, we're going up to 1. So it's going to look like that. 3 solutions. We've got 1. We've got 2. Come on. And we've got 3. Okay, so this one is x equals, that's closer to, I'd say it's 1.9. This one, x equals negative 1.3. And this one, I'd say x equals, that's really close to negative 1.6. This one's a similar kind of deal. So let's do pi on 2, pi, 3 pi onto 2 pi, negative pi onto negative pi, negative 3 pi onto negative 2 pi. It's cos 4, 0, negative 4, 0, 4. And we also want the line 2, y equals 2 take x. Now this is going to be really annoying to draw. 2 take 0 is 2. Two take pi is going to come down to like negative 1.14. I'm just going to make sure my line goes through these. This is not an exact way to solve things like this. So we've got 1, 2, 3 solutions. Now, figuring out why they must be between -2 and +6, we can talk this through algebraically. If we've got 4 cos x equals 2 take x, we know cos x is between -1 and 1. So at the least, we're going to have 4 times -1 equals 2 take x. -4 equals 2 take x. X equals 6. Like that's the one end. And if we've the other end, we're going to have 4 times 1 equals 2 take x. So 4 equals 2 take x. So x equals -2. So x can only between the values for which this works can only be between -2 and +6. Like otherwise, we're just not going to get solutions. Okay, show that x equals pi on 3 is a solution of that. That's fairly nice, easy 1 mark. Sine pi on 3. That's sine 60. I hope. Yep, so that's √3 on 2. Half times tan pi on 3 is half times, well, tan pi on 3 is √3 on 2. Therefore, sine pi on 3 equals half tan pi on 3. So pi on 3 is a solution. Okay. On the same set of axes, sketch the graphs for sine x and half tan x between -pi and pi. So if I make this -pi on 2, 0, pi on 2, and pi. Okay, and if I make this 1 and -1 and this half and -1/2. I'm going to do sine in light blue. So sine and I'm going to put in my asymptotes for tan x. Now tan, don't forget, has asymptotes at pi on 2. Ignoring the stretch. Okay, find all solutions for these between -pi on 2 and pi on 2. So we're just restricting our domain here now. I'm just enjoying coloring in this. Well, they asked us to show that pi on 3 is a solution deliberately. We know pi on 3 is that solution, which means it makes sense for -pi on 3 to be this solution. And 0 is the other solution. I think they're the three solutions. Use your graphs to solve when it's less than for in between there. So the green is my half tan x. I should have specified that. Sine x is the blue one. Green is below the green. Half tan x is the green one. We're looking for when sine x is less than half tan x. So when sine x is below. So I think sine x is less than or equal to half tan x when the blue is below the green. So when we're between negative pi on 3 and 0. So that's this region in here. All right, we're on to the trig identity stuff. Weirdly easier. Well, not weirdly. Okay. Good useful things to be able to remember is that sine squared plus cos squared equals 1, which means, sine squared is 1 take cos squared and cos squared is 1 take sine squared, and 1 plus tan squared is sec squared. What we always do is we start off with what we've been given, and we're usually manipulating the left to make it the right, or the right make it left, or you can manipulate both at once as long as you end up with the same thing left and right at one point. And what I'm going to do is I see sec squared. I'm going to straight away replace it with 1 plus tan squared. And now you'll see that 1 take cos squared is actually sine squared. So sine squared theta plus tan squared theta equals 1 take cos squared is sine squared. So we've got sine squared and tan squared. Left hand side equals right hand side. Okay, number 2. We've got 1 minus tan squared theta on 1 plus tan squared theta equals cos squared theta take sine squared theta. This time it's going to be much easier to manipulate that fraction. So 1 takes tan squared theta. 1 plus sine tan squared theta is sec squared theta. Now this is the same as 1 take tan squared theta divided by sec squared theta. It's good practice to just keep writing that out in case you need to change both sides, which means we've got 1 minus, now tan squared is sine squared on cos squared, times upside down cos squared theta. Lowest common denominator, I'm going to join those two on the left. So we've got cos squared theta minus sine squared theta on cos squared theta times cos squared theta. And cancelling out, we are left with cos squared theta minus sine squared theta equals cos squared theta minus sine squared theta. Left-hand side is right-hand side. All right, I think we're nearly there. So this time we've got, I really need to charge my Apple Pencil. This time we've got tan theta is 1 on root 3, and we're trying to solve it. Now, we know using our exact values that tan's going to come out as 1 on root 3 whenever we've got, now I'm just trying to remember because I don't actually have my exact values in front of me. Pi on 6. So we know that's pi on 6, but we need the other value, which is going to be down here, which is pi plus pi on 6. So it's 7 pi on 6 as well. For tan x equals -3, tan comes out as, when does tan come out as 3? We're in degrees, not radians. Pi on 6, that's 15 degrees. 7 pi on 6 is 195 degrees. So arctan -3, this one's not going to be as nice. So we've got -71.56 degrees. So that's 288.43 degrees. That's all the way around here. The other value that would give us a negative for tan is this one. So if we just subtract 180 from there, we'll find the other one, which is 108.43 degrees. Okay, solving these ones. Now, don't forget, we've got to go a few ways around the circles. So this time we're going to have to go twice around the circles. So if we've got tan 2x equals root 3, that means 2x equals arctan root 3, 60 degrees. And let's add 360 onto that. 420 degrees. Which means x, we're going to halve that. We've got 30 degrees. And wait, why did I bother doing that? 2x equals 60 degrees. We also want this angle, which is going to be 240. But we also want to go another way around the circle for both of those. So we're going to have 60 plus 360 is 420 degrees. And we're going to have 600 degrees. So the answers for us, we're going to have x equals 30. We're going to have 210. We're going to have 120. And we're going to have 300. Okay, this time we've got sine 3x equals -1/2. So we know 3x is, sine 1/2 is 30, -1/2 are going to be down here. So we're going to have 3x equals 330 degrees. And we're also after this answer will also give us a negative for sine. So going 30 down there, so that's 210 degrees. But we want to go 3 rays around the circle. So that's 690 degrees. And 1050 degrees. 210 plus 360, 570 degrees. Plus another 360, 930 degrees. Which means for these, we're going to have x equals 110. 230, 350, 70, 190, 310. Okay. And question C was 2 cos 2x take 1 equals 0. So we've got 2 cos 2x equals positive 1/2, which means 2x equals 60 degrees is our base one. Which means 300 degrees is our other one. So we've got 2x equals 60, 2x equals 300. We want to go twice around the circles. Let's add on 360 to those. So we've got 2x equals 420 is our other one. And we've got 660 is our other one. So let's halve these. So x equals 30, x equals 210, x equals 150, x equals 330. Okay, and now we've got sine x take whatever, we've equals √3/2. Now, sine comes out as √3/2 when it's 60 degrees. But also at 120 degrees. So we've got x take 250 equals 60 and x take 250 equals 120. So x is 310 and x equals 370, which is 10. Yeah, sorry, I just had to double check that other one on my calculator. Good. Oh, the answers were there. Okay, this one's going to be easiest if we divide everything by sine first. So that means, no, let's get everything over to the left and factorize. 5 sine squared x takes sine x equals 0. So let's take sine x out. So the answers we're going to get is when sine x equals 0 and 5 sine x equals, take 1 equals 0. So sine x equals 1/5. Now there's 3 values that give sine x equals 0. X equals 0, x equals 180, and x equals 360. 1/5 is not so nice. And we're going to need both these answers. So the first one we'll do in our calculator, arcsine 1/5. That gave me 11 degrees, 32 minutes. The other one is 11 degrees, 32 minutes back from 180. Which gives me 168 degrees, 28 minutes. So they're my 5 answers. We're really close to being done. What I'm going to do here is if I multiply everything by cos, I get rid of that fraction. So I get 4 take cos squared x equals 0, which means cos squared x equals 4, which means cos x equals plus minus 2. There's no values that will give us that. No solution. Because we know cos is between -1 and 1. That was easy. In this case, last but not least, I think. Yes, okay. This one's a bit harder. This time, because we've got sines and coses, I want to get rid of, I want to turn everything into tan. That's the best way. These are only kind of doable when it's in terms of sine or cos, but we can't do it all together. So let's do it in terms of tan. To turn stuff into tan, I can divide by cos squared, because if I've got sine squared x on cos squared x, take 3 sine x cos x on cos squared x plus 2 cos squared x on cos squared x equals 0. I get enough stuff cancelling out. These coses go. That one goes. And sine squared on cos squared is tan squared. So I've got tan squared x, take. Sine on cos is just tan, 3 tan x plus 2 equals 0. Now, this is actually a quadratic. If I factorize this, then I get, you could do u equals tan x, u squared, take 3, u plus 2 equals 0. Factorize u, take 2, u take 1 equals 0. So u equals 2 and u equals 1. So we've got tan x equals 2, which is fine. Tan x equals 1. We're going to have to find the solutions that give us tan x comes out as 2, tan x comes out as 1, and there's going to be 2 solutions for each. So if I do arctan of 2, then that's like 63 degrees. The other answer is 243 degrees. So x equals 60. I'm not being very accurate. I've lost all my decimal places, but I'm just doing it to the nearest degree. Tan x comes out as 1. We know, or we should know, that that's 45, which means the other one is 225. That's it, and my pencil lasted. Hooray. Well done on making it through those. Now I've just got to figure out how to end this. End. Bye.